Good morning, class. Welcome back to AET 830, Internet of Things and Industrial Applications. So in this unit, we'll talk about an important topic, the security. Actually, we have mentioned the importance of security in our previous unit. So in this unit, we'll talk about the basic principles of security, and also we'll talk about the threats to IoT systems and how to deal with these threats. We will also talk about the security for safe IoT application. Basically, what we should pay attention to in the IoT settings. And we will also mention the another relevant issue, the privacy in IoT. And we will also cover the security in architectures and standards and the future deployments in security. But those two parts will be left for you to read yourself. So the content of this section comes from chapter 6 of the textbook. So first of all, let's begin with the introduction. Basically, this is for your reading. Basically, it highlights the importance of security, which you should have an idea so far. Okay, now let's come to some basic principles of security. Basically, here are some terminologies. First of all, we need to have the message confidentiality, which is the most important aspect of security for the IoT and is typically the first problem addressed when attempting to secure a network. So as its name indicates, message confidentiality means that the content of the message should not be known by other people, right? It is ensuring that no acquired knowledge can lead to adversaries or unauthorized neighborhood nodes. Basically, it will not be accessed by those people who should not know it. So many applications require in-network distribution of key information. So basically, it needs the construction of a security channel over which this information can be sent and ensure the malicious parties cannot gain access to this information. So first of all, we don't want them to, ideally, we don't want them to get in touch with this data. So, but sometimes it is not avoidable for them to get in touch with this data. In that case, we just move a little bit backwards. Okay, you have the data, but we will not let you know what the data means. In that case, encryption is an important tool. Actually, we'll talk about it a little bit later into more details in this chapter. So data in another terminology is data integrity. It is required to ensure that the adversary cannot change or alter any information sent across a network. So this is another situation. So that the bad guys, okay, they can, because you use encryption, they cannot know the content of your message. But some people, they just want to create some damage. They think, okay, I don't know your message, but if I can do something bad to your message, for example, if I can alter some information and basically put it into some chaos letters, then he or she can also do the damage, right? So data integrity is to make sure that the content of the information cannot be altered when it is moving across the network, so that you receive what the senders sent. Freshness of data, well, it is not like the meat. Maybe like the meat, it may be an interesting term to some of you. So this ensures that data received is recent, and then no old message have been replayed, hence throwing the classic replay attack. Basically, for the information, just think of the echo of your voice, right? So usually when you call, for example, you're calling your mother in the house, so you call mom, so theoretically this message just goes through once, right? And reaches your mother's ears. But for some security attack, the bad guys try to echo the message, basically replay the message, so that if it is in the previous example, although you just shout mom for once, but the bad guys will just replay it, so the whole house will be echoing the sound mum 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 for many times, thousands of times. So that will cause some jamming in the network. So that's why we need to find a way to make sure the freshness of the data. So what we can do is to use a timestamp or a counter. Timestamp means that it indicates when the message is created. So if it has been there for maybe 10 seconds, we just throw it away. And the same can also apply to a counter. So it has been routed, been moving in different nodes in a network for maybe 1,000 nodes. So it should be disposed. Efficiency concerns the relationship to the resource consumption associated with the implementation of security architecture in IoT. Basically, if we need to apply some security methods, as we will talk about later, it needs to consume some resources in the network. So it may slow down the routing. For example, the Trojan protocol should fit within acceptable performance parameters. If the proposed scheme standard is too resource hungry in terms of processing requirements, memory space needed, and power consumption, it hampers the performance of a network. Nowadays, when you click a website in your browser, usually it takes maybe 0.1, 0.2 seconds for you to open a website, right? But if the security protocol is too complicated, so you need to check many things. So you may need to wait for 1 or 2 seconds before you can see a website. So nowadays, so many people cannot bear this 1 or 2 seconds. Autonomy applies to ensure that every device in an IoT deployment may operate independently and be flexible enough to accommodate fluctuation in the network architecture. As we mentioned, there are thousands of devices in an IoT network and also in the internet, of course. So autonomy means that the device can survive themselves, can manage themselves, so that if there are some fluctuation, for example, if a router or a node in the network is not working anymore, then other devices will be able to accommodate this situation. So let's draw a simple network. Okay, so yeah, so we have the nodes and also the links, right? So usually the links, yeah, more or less this, like this. So if we have a device here, so device has the message. So we talk about routing and hopping, right? So the message previously it is going through this path to reach this node, right? But if this node in the middle stop working, then the message should automatically, so we don't need human interference. The message should automatically go along this blue path, not blue, green path to reach the destination. So that's one aspect of the autonomy. And there are many other scenarios. But it just means that the nodes and just means that the network, the functioning should be strong enough to survive from the fluctuation. Authentication is an extremely important requirement for secure IoT system. So basically, when you go to your mailbox, when you go to the an account, your bank account, basically you need to input what? Input your username and your password, and sometimes you need to receive a security code in your mobile phone, right? Basically, that's one way of doing authentication. Basically, it is necessary to authenticate every transmitting device in the system before accepting that a message is valid. Basically, it needs to make sure that the message is from the authenticated device. So when you log in, basically it knows that, and when you log in, it associates the device with you. Do you get my point? So when you log in to you use your username and your login, right? In that case, the system knows it's you. You maybe Jack, Rose, right? But at the same time, it also associates laptop or or the iPad, you use to log in with you. Basically, because the laptop will be doing the transmission, right? You may also upload some information using the laptop, using the device. By logging in, the system can associate the laptop with you. Basically, any message, any information sent from this laptop, it represents you. So it is authenticated. And availability of IoT device can be ensured that such an app can continue to function as intended. So in the case, it is required for a central application server or network coordinate device to reach all the other devices in the network. Okay, after talking about the basic terminologies, let's come to two of them more closely. The first one is encryption. So many of you may be interested in the detective stories, right? So encryption is always a topic in those kind of novels, those movies. Encryption has been used for many centuries as a method of ensuring the confidential of secret communication. So technically, it is transformation of information or plain text, making it unreadable or indecipherable to any person who does not have the key. Basically, the transformed text is known as ciphertext. So basically, you cannot read the ciphertext directly. For example, just to make it very simple, so we have the message, original message as ABC, right? If we just use the location of these letters in the alphabetic list, so they can be converted into 1, 2, 3, right? So this is a simple version of encryption. And in this case, the key is the sequence of these letters in the list, in the table. But in this case, it is easy to guess, right? And this is achieved using a certain kind of algorithm referred as a cipher. So in this case, the cipher is the sequence of the letters in the table. There are many different algorithms available for encryption. So yeah, there are some standards, and some people will invent themselves. In that case, they may be only known to them. Anyway, in cryptographic terms, a cipher is defined as an algorithm for performing encryption and decryption operations. So pay attention that a cipher can be used for. It is a predefined set of functions that must be followed precisely on each occasion. So usually it is a mathematical function, and sometimes it is kind of other functions. So you may have seen that some people will create some holes on a book page, right? And when this page is aligned with a common letter, for example, letter means another page of paper. So when these two pages are aligned, so we can only see the letter behind the holes, right? So and then those letters, when they combine, they can be a word or a simple sentence. So that's another function. Okay, so just be clear here. When you cipher, the original information is called the plain text, okay? And after the encrypted information is ciphertext. Yeah, so you just need to know these terminologies in this course. We don't need to go into detail. The ciphertext should be indecipherable to anyone who does not possess the knowledge of the cipher or algorithm or the key. So the key or shared secret with trusted parties is the pre-agreed crypto variable, without which it should not be impossible to decipher the plain. So with that, so for the encryption, we can do it in two ways. So if the cipher performs operation on a block of information, usually of a fixed size, it is known as a block cipher. For example, it encrypts every 5 letters. So in that case, it will be a block 1, 2, 3, 4, 5, 5 block cipher. Or if the cipher operates on a continuous stream of information, it is stream cipher. For example, for the example I used just now, so ABC, so basically the cipher, maybe F, the cipher apply to every single letter, right? A continuous string of information. So it will be 1, 2, 3, maybe 6, something like that. It is stream cipher. In other words, a stream cipher operates on a single byte at a time. So in this case, it's A, B, C, F, right? When a block cipher operates on a group of bits, is enough to understand. So for the ciphers, we can also do some classifications based on key and type generated. So if the same key is used for encryption and decryption, the plain text, this is known symmetric key algorithms. What it means is that, so with A, and then we use key 1 to encipher it, maybe into something we don't know. And then we still use the key 1 to decipher. Basically, it can be used in a reversible type style. So it is symmetrical because we use the same key to do encryption and decryption. But usually it is not very safe. So nowadays, more people are using the asymmetric key algorithm. So as its name indicates, so we need to use 2 keys. We use one key to do the encryption and use the other key to do the decryption. So which is nowadays you may have heard about this term, the private and the public key infrastructure. Here we have Bob and Alex. So for Alex, it has the public key. We have Alice's public key and Alice's private key, public and private key. And also we have Bob's public key and private key. Okay, the public key, as its name indicates, it is available. It is sent to other people. For example, Alice can send her public key to Bob using some common methods. For example, using an email, using a mobile phone, maybe. So for public key, it does not require them much protection. But for the private key, for Alice's private key, she will be the only person who knows this key. So how does these 2 keys work? As we mentioned, so Alice can send her public key to Bob. So what Bob will do is that, so we have a message from Bob, and Bob uses Alice's public key to encrypt. Okay, this is the trick here. So Bob will use Alice's public key. It's not using his own public key, okay? He uses Alice because the message is to be sent to Alice. So he needs to use Alice's public key to encrypt. And then encrypt so it can be sent using email because it is assumed that the content of the encrypted message cannot be identified, cannot be found out by other people. Okay, and then after encryption, maybe the message will look like this way, so we don't know what it is. So Alice will receive the encrypted message, so like this way, so they're the same, okay? And Alice uses her private key to decrypt the message, and then she can know the information. That's how the public and private key are used. Basically, the public key can be shared to your collaborator, and then you need to keep the private key yourself. So we have more introduction of the common symmetric ciphers and asymmetric ciphers here as a reading part. If you are interested in this, you can read it. Yeah, you may have heard of RSA. Basically, that's the typical private public key method. Okay, another thing we will look into more detail is the authentication. It is complementary to encryption and can prevent many of the attacks described in the following section. So it is a mechanism whereby the identity of a device or agent in the network can be identified as a valid member and such data authentication can be achieved. Once again, when you log in to your bank account, username and password, so it just authenticates your laptop, basically the device you use to log in. In that case, any information sent from this device will be considered to be worth trusting. So that's how authentication works. There are a number of methods. So for example, we can use the message authentication code. Basically, it is the MAC address, right? So for every device in the world, okay, it has a MAC address. So if some of you are computer guys, you know MAC address, right? Basically, that's a unique number that's associated with your device. If you log in with your laptop, basically the MAC address of your laptop is what? Authenticated. Basically, the information sent from your laptop, basically according to the MAC address, will be trusted. And for some device, instead of using the MAC address, it will use the MIC. For example, my mobile phone. If you go to your Android phone or your Apple iPhone, they will be using the message integrity code, MIC. So it is the same thing, actually. A little bit different, but they are just serving as the unique identifier number of your device. So once it is authenticated, the information sent from this device will be trusted. Another thing worth mentioning is the hash function. So it is a cryptography hash function is a procedure that returns a fixed size bit stream for a block of data. What it does is that it's a very interesting function, actually. If you have a file, no matter how large it is, for example, it is just 5 KB or it is 5 GB, it doesn't matter. By using the hash function, it will just return to a fixed length of letters and number combination. If I remember correctly, it is 24. What it does is that, for example, you are sending a file to your friend, okay? And this is very useful when you download some games from some third-party platform. Actually, usually they will provide the MD5 code to you, which is part of one kind of the hash function. Okay, for example, when you want to download a file or we send a file from A to B, right? Okay, the B download the file. So by looking at the size of the file, they look similar. For example, they are 5 GB. Okay. Usually for A, it will also share the MD5 code to B. So after downloading the file, the B will run a program to generate another MD5 for the downloaded file. And for A, it will send the MD5 code of the original file. So do you get my point? So A will generate an MD5 code from the original file and then send it to B. And also B will generate another MD5 code from the downloaded file. So B will compare the MD5 code he generated with the MD5 code sent by A. If the two codes are the same, that means that the file B downloaded is identical with the file A is planning to send, basically identical with the original code. If some bad guys try to make some modification or to the file in the middle of the transmission process, then the two MD5 codes will be different. Then B will know that something wrong happened. And this is also useful to find out whether B downloads the complete file, because sometimes the files will be separated into several small parts. And if one part is missing, then the function will not work. So this can also be used to find out whether it is complete. So to summarize, it is to make sure the integrity of the message. Another way of doing the authentication in an asymmetric way is the digital signature. So it is a signature. So it differs from the previous described in the digital signature is generally using the private key or public key pair. So that's why it is asymmetric. So this demonstrates asymmetrical functionality. In that case, so nowadays we are working remotely, right? So many times you need to do the digital signature. So that's actually one kind of authentication method. So it just makes sure that the file you signed is signed by you, okay? So some methods for the authentication for reading. Okay, in the next video, we will talk about some common threats to IoT system. That will be an interesting